I'm Rob Pizzamenti, and today we will be looking at how to find the radius of convergence and the interval of convergence of the series x plus 2 raised to the n power divided by n times 4 to the n power. Before we begin, I want to make clear what we're trying to do here. What we're trying to do is find for what values of x will this series be convergent. So we have this radius, this bounds of any value of x that is within here will cause the series to be convergent. Anything that's outside will cause it to be divergent. Now, because we want this series to be convergent, we set up a test as if we're going to test for convergence, and then we're going to eventually filter out the x and set up an inequality, which we'll get to. But in this case, which is very common, I'm using the ratio test, so I set it up as such. The next step in the ratio test is kind of breaking down our equation. So x plus 2 to the n plus 1 power can be broken down just to x plus 2 to the n times x plus 2. And again, we did that with 4 to the n plus 1. The ratio test usually works out very nicely here. We see the x plus 2n cancel out in the top and bottom, so it is the 4 to the n. If you do the ratio test, a lot of times it'll work out very nice like this, which is why it's so common to use. Now I've just rewrote the equation after taking out the intervals or the numbers that canceled out. And as we see, we have x plus 2 nice and isolated at the top, which is going to make this easier for us. So now I'm going to pull out the x plus 2. I can do this because the limit is as n approaches, so x won't affect this at all. And also, the absolute value signs will be moved out with it because n is always greater than 0 in this series, so we don't have to worry about it now. After solving for this inequality, we get the absolute value of x plus 2 times infinity over infinity, which is indeterminate, so we're going to have to apply L'Hopital's rule here. After using L'Hopital's rule, we get a very nice number, 1/4, and the limit as n approaches infinity of 1/4 is not affected at all, so it just ends up being 1/4. And now we have our new inequality with the absolute value of x plus 2 times 1/4 must be less than 1 in order for this to be convergent. I spoke about this earlier in the video. Remember, the whole point of this is to find the x values that will cause the series to be convergent. Now, after some basic algebra, we get this inequality. We multiplied 1/4, or we divided 1 by 1/4, and then because of the absolute value sign, we get that range. Further algebra finally gives us this final inequality, which is telling us that our interval for x is going to be between -6 and 2. So our radius of convergence is 4, which means that x can move up 4 or back 4 from its center, which is -2 in this case. But we do not know if -6 and 2 are included in this interval. It might be right up to -6 or -2, or it might include those numbers. So now we need to test and see if -6, if x is -6, if it will be convergent. So what we do is we just plug in -6 into the series, and we will see if that will cause it to be convergent by doing some tests. So when we plug in -6 into our x spot, we end up getting -4 to the n divided by n4 to the n. And this can be rewritten as -1 to the n times 4 to the n, which makes this look a lot like an alternating series, which means we can run that test on it. After some simple algebra, we see that those 4 to the n's cancel out, leaving us with -1 to the n divided by n, which means our b to the n equals 1 divided by n. So the first thing we want to know is that our b to the n will always be greater than 0, which means it's positive. And because n is always greater than or equal to 1, we will never have a negative number. So it passes this first part of the test for convergence. The second test is that as n increases, it will keep being smaller, so we want it to be decreasing. So this inequality shows us that. So some more algebra will show us that in fact as n increases, the series will be decreasing. So it does pass that test for convergence as well. The final test is that the limit as n approaches infinity of Bn equals 0. This is a pretty simple one. Just through direct substitution, we do see that this is true. Now, because the series passed the test when x equals -6, on the left side we have the bound being inclusive. We still don't know if 2 is included in our interval, so next we'll have to test for convergence when x equals 2. So just by inputting, plugging in 2 for x, we get 4 to the n divided by n times 4 to the n. This cancels out very nice to give us this series of 1 over n. We can rewrite this as 1 over n times 1, which sets it up very nicely to test by p-series. So in this case, p equals 1, which is equal to 1, and we know that this means that the series will diverge. Now, because this diverges, this means that the right bound is exclusive. It does not include 2, so we have our final interval. There's a lot of steps to this, but if you're solid with your foundation in finding and testing for your convergence, then all you need to do is use those skills in a new way, and you'll be able to do all of this. So get strong in those foundations, and you will be set.